Okay, so we're here looking at MegaFlow heat resadia immersion meter, and we're going to do a quick test to assess the problem. First, we have isolated the switch. We made sure there's no power to it, and then we took off the cover. Now, we still need to double check that electrically. Now, for this basic test, we don't need a mega equipment. A multimeter like this would suffice to check. So now, to test this immersion meter, we need to set the voltage AC. Okay, so AC. Now we put the leads to live, neutral first, and live. And we can see that there is power going from the switch. Now, I did say that we isolated the switch before we turned it on. We just turned the camera on rolling, so that's why we can see power. Now, I would highly suggest to test also polarity of this switch. So the way to do it is you put it on neutral and earth. Now, as you can see, we should not get any power. As you can see, there's no power going through it. It's not 0.33, that's negligent. Now, if we put live to earth, we should be getting power. That means the polarity is correct, because live is producing power and sending it back to the earth, and neutral doesn't do that, so that means that's what it's supposed to be, the polarity is correct. So now we need to investigate further why there's no hot water. Now, on these particular thermostats, this is a thermostat by the way, if you can see that, green and white, or blue and white. So we switch it off, we make sure there's no power going to it. Again, let me check. Yep, there's no power. So I'm happy to work on it. Obviously, I'm not going to touch the wires now. You need to do that. You need to isolate it from the consumer unit. So you normally do that. Then we're going to reset the safety pin. If you can do it. Did you hear the click? So that's a safety pin. That means it overheated. Right. Now there could be a number of reasons. One, it could be that the temperature on this thermostat is turned up really high and it's on its way out. If that's the case, then obviously most likely this has just tripped the safety device. But on this occasion we're going to reset it and leave it, because we should be okay with that. Now, one more test I would normally do is a resistance test to check the element, if the element is still okay. So if we turn our multimeter to ohms, ohms, now we're checking resistance of the coil inside this. Now, I tend to, because it's switched off, I tend to check it straight from live and neutral. And that really tells you, because at no point decimal, it's not going to change much of a difference, create much of a difference. So you just check resistance this way, and we should get about 19 or so ohms, 19.4, 19.2. So we're okay with that. The coil inside the immersion meter. All right. So we've done our checks. We're pretty much happy with what we've got here. We can turn it back on, test the power, and see if we get hot water. Right? So the power is on now. We're going to check if the power continues into the element. Usually you'll start hearing hissing, or things like that, as you probably can hear, if the element is okay. If that doesn't happen, sometimes on new elements doesn't, what we tend to do, I isolate the switch again, pull the thermostat slightly out and measure, make sure, by the way, to cover these pins so only a little bit of it comes out. You don't want to touch any elements. So then carefully you could check if there's power beyond this thermostat. Now if you're not really comfortable doing that, you could do that isolated from the consumer unit, or just a switch. That's how we approach it. Take this out and then test each pin, because each pin, so for continuity, and that will tell you whether that thermostat is correct or incorrect. So that's the basic way. When I mean correct or incorrect is that if it's working fine or not, if the safety valve is tripped or not. That's one way of telling it. Sometimes, the element inside could burn out and then it wouldn't work, so there'd be no continuity. If there's no continuity, obviously there's not going to be power going through it. So next, to check continuity, you set on this particular multimeter, you could check a beeping noise. This particular one beeps. Yep. Or it shows like very low resistance, because like the cables are just yelling at about 2 meters long. So, yep, that's these are the kind of tests that we apply to an immersion heater. Obviously, if there's a fault with a switch, you would get no power. Then we would have gone, to check the switch. Then we would take the switch off, check if there's power supplied to the switch, and the switch may have become faulty. That's one way of testing it. Now that's for a boost, which is always live usually. Now for an immersion heater, that's off peak, which only comes on at night. You could do the same tests at the bottom, and fingers crossed, power will come on. Now usually, once you test, you could test the switch, the same element where you take the switch off, test the switch itself, supply to load, live, neutral. You would sort of it would indicate that it's either working correctly or not via the continuity test. Well, that's how I would approach it, and leave it. Say and ask the customer. Did you have hot water, next day, or ask them to ring you if you don't? But usually, 9 out of 10, it works fine. Obviously, if your checks prove that this is all correct, then possibly there's something wrong at the consumer unit with that timer. Okay, I think that's it. We're going to go and check the bottom one, applying exactly the same test as we did for the top one, and we're going to move on, because I think the customer will be happy tomorrow or later on this evening. Thank you for watching.